Please subscribe, like, and share. Several videos back, I have shown you guys, the way I modify my cylinder heads by installing intake port spacers in order to move up and decrease the port angle. And I don't think you would hardly see anybody that would disagree with that. For just about any make, any kind of engine, when you increase the port or decrease the port angle, and you're going to end up an increase in port flow due to the fact that now the airspeed inside the port is a lot faster because it doesn't have that slow turn or the drastic turn to slow down the flow quite a bit. The only drawback that I see here, sometimes you got to address the issue of the short side, how it transitions when you raise the port that tall. I'll touch on that in another video to highlight what we need to look at, because sometimes there's a point of diminishing returns and you can overdo a lot of these things and end up with quite a bit of advancements and also some drawbacks. So I'll touch on that, but for now let's just look at what I have said on the short video I had earlier about getting a raised port or a high port cylinder head without plates. And what I'm trying to show here is that how we can do this cheaply. Well, let me just say something clear. My purpose here is not to tell you the best cylinder head out there. There's a lot of billet ones and a lot of expensive cast type aluminum. What I'm here is try to do some kind of low buck or common sense improvements that we can do without really spending an arm and a leg. We can do all these, no problem. Like Warren Johnson said years ago, to go into pro stock, anybody can be a winner if you have the money. Because today, you can buy the cylinder heads, you can actually lease an engine or buy an engine from one of them great engine builders out there. There's a lot. Okay, I'm no genius. I try to learn as much as I can and pass it on to everybody here. But I'm not powered by money. Not a chance in the world. I'm not powered by money. A lot of people always say, oh man, he's fast because he probably got a lot of money. No, I do a lot of my stuff, all right? And I'm forwarding a lot of these techniques and tricks to you guys. Well, I don't know if I should say tricks, but common sense procedures that we can to get horsepower, all right? There's nothing really earth-shattering with this thing. And just like what I'm about to tell you here today, I have shown intake port spacers work, but now we have another point to look at how we can achieve high ports without plates. Basically, what we're going to look at is play around with deck heights and the manifolds available to them. Now to start, the Fords come with an 8.2 and some 8.7, 9.2, which is Cleveland deck height, and 9.500. And I have some there at 9.700. Okay, that's quite a bit. But that's just a special type of build. It's not for racing per se. Okay, except you're looking at heavy car and basically trying to move a lot of weight. Then you need a lot of stroke. Oh! At the expense of RPM. And like I stated, RPM is king at the racetrack, torque is king on the streets, and some kind of mild racing, not really all out. The Fords blessed with an 8.2 and 8.7 aftermarket, and a 9.2, which is Cleveland deck height, and a 9.5, which is Windsor deck height. Those first and third and fourth are basically production deck heights. The Chevy has got a 9025, I think. All right, it's kind of short, But the problem there is that being short deck too, the camshaft went down at the center line, where basically what you have here right now is the crank center line, and the cam center line is too close, and you end up running basically a small diameter camshaft or small diameter base circle to clear the rods. And I have a little bit of issue with that, especially when you got a lot of RPM and you're trying to RPM a stroke or small block. And you have the oil pump on the back turning, that's a drag, and then all the valve spring, you have a lot of possibility of twist. And if you really look at the measurement between the cam timing or load timing and look at that on the end, you might have some amount of twist there, all right? And it's not going to be perfect. Like anything, there's a drawback. The head bolt pattern is great, right, compared to the Fords. But now we also have the LS, which is a 9240, I think. Yeah, excellent. Slightly above the Cleveland, give or take. They're pretty much equal. Pretty good. You got a lot of basically real estate there to put a stroker crank. But the only problem that you're going to end up with is like the length of the basically the cylinder wall. The piston probably comes down way too low, and this exposes the skirt of the piston, which would start to wobble at high RPM when you run a lot of stroke. Same thing with the doggone Cleveland. You cannot get too much on the stroke, all right, because the deck height's short. The Windsors and the 340, 360 Chryslers, they got a lot of room. You can really go big with them. Factory 430 plus cubic inches, not a problem. Now, let me also add on, Ray Choi is a good buddy of mine for so many years. We used to work together in my shop. Told me, and he reminded me, that the lightning block that he had would clear 100 over. Think about that. They always say thin wall Henry or thin wall Fords. I don't know who started that, but that is not an issue. He had his sonic check and it'll go over 100 or right at 100. And I know of other early style blocks that would do 100 as well. That's why when people used to come and say, oh, I got a 60 Windsor block, you want to buy it from me for racing? Because it's thin, it's already 60 over. I go, sure, I'll buy it. Because you know what? I sonic check it and they go over 60. They go over 60 thousandths. All right, so it's not rare to say, oh, they don't have enough meat. They do have a lot of meat. Now the 302 HO, that's another story. 40 over, that's pretty much where I'm at. Okay, we got sidetracked there for a moment. Now, let's go back to this racing the port without intake spacers. Now, like I said, the Ford's been blessed basically with production deck height of 8.2 for a 302, 9.2 for the Clevelands, and 9.5 for the Windsors. And I've known this for years. I've done very, very few of these block deck height to manifold swap. Unbeknown to many people, it is such an advantage, okay? And maybe it's unappreciated because everybody sees a monkey see, monkey do scenario here. But when you learn not to march with everybody at their beat, and you try to do your own timing and look at everything and think outside the box, you're going to end up with this kind of scenario. Here it is. I run a 9.5 manifold. I did this years and years and years ago. 9.5 intake on a 9.2 deck. And when I say that, people look at it and go, oh, I don't know if they understood. That's why in fact, in my old shop in Palmdale, Lancaster area, I did this, all right, and took videos of it. It's probably still out there in my album. But when you do this, and what you're going to end up with, a higher port angle, and there's nobody out there with their right mind will disagree with me when I say race the port. Almost everybody races the port. That's why it's called race port cylinder heads. The only issue I have here is perhaps the AFR. You might need to cut partially part of the valve cover off. All right, and that might be an issue. In fact, let me try an AFR here and put that on a 9.2 deck and see if I can clear the manifold. Well, that said, I've always gravitated towards the TFS and some of the other brands, but basically the R and the TFS high port because they give me a lot of room, and the valve cover rail is higher up from the stock position, so I can fit in the 9.5 deck manifold with no issue. Then I can just epoxy the floor, or if you have a little bit of money, weld it, and then raise the port way high. How much? Here you go. Look at it. We are looking at a 9.2 deck block with TFS high port heads. On top of the manifold is a circle track 2V with an angle spacer there. But actually, when you look closer, this is a 2-barrel layout. Strictly round the round configuration. Okay? Now, look at the fitment. The manifold belongs to the 9.2 deck height manifold. So, there's no issue with that. Now we will look at something else. Alright? And try to gain an advantage on this type of engine block. That's what I like with the Fords. There are different engine blocks. Small block Chevy comes with their legacy small block deck height. It's all the same between a 283, 327, 302, 350, 400. The Fords have different ones. 8.2, 9.2, 9.5, and the 400M is a lot taller. So you got a lot of things to do with the manifold and how you can take that and use it for your advantage. So here we go. Now we are on the same 9.2 deck Cleveland deck height Windsor block. But look what happened. I'm running a Super Victor 351 Windsor. And look at the gap right here. It's quite exaggerated, isn't it? Same thing on the back. It looks normal. You can tell people you're running a Windsor block, but you're not. This is strictly high RPM now. There is quite a bit of port height available with this combination. Remember, this is already ported. And using this manifold, which is also ported, you can really bring this intake port way, way high. Okay? So, let me take this to the inside of the shop where I have better light and we can peek through that intake port. Okay, here we are. Excuse the shop light, but let me zoom in there. Look how high. That is a whole bunch. And the floor, you can just build it up. Now let me see if I can see it on this port. Same thing there. Okay, I wish I had a flashlight so I could zoom in better. Look how far that is. Alright? How much are we looking at, height-wise? That's a whole bunch. Alright? So, let us see. Let me make a measurement. After I took the manifold off, what you guys saw was about that much distance, right? So, that's the stock height, and this is, remember, it's a 1262. Is it? Yeah, this is a 1262 gasket. And it went up that high when we did a peekaboo on the manifold. Guess where it's at? Yes. It's about what this is. Oh. Half an inch. Yeah. Half an inch. Alright? this is as good as my plated intakes. Now, if you want to add some more, if you want to raise it up some more, you can put my plate, and you could probably get to about 650 to 700 thousandths of an inch higher. 6 to 700 thousandths of an inch higher. But you just gotta knock that section off. All right, you gotta put a little angle there so you can move the plate up and cut the section here for the lower deck height. And now you got how much? 650 from stock height? You tell me you're not gonna pick up airflow there. All right, this is what I'm saying. Check it out. If you want to run a Windsor type intake manifold, I suggest you run a 120 thick because it'll raise the port a little bit more as opposed to a standard thickness, I think 60 thousandths or 45 thousandths. This is 120. And same thing if you want to run a Yates flange pattern or a Yates intake, you just get a plumb, basically a outlet for the coolant on the front of the cylinder head, and this is the gaskets to use. Or otherwise, you can just run a regular Yates intake if you're happy with the port height you have. Anyway, the 120 thick will raise it up some more. Okay, so here we have the AFR, and my main concern with the AFR was this lip right here. All right, the valve cover rail is right at the edge, and then it cuts down towards the flange. Same thing, of course, you're gonna have that deep thing there, but it looks like it fit right in there. If need be, maybe you could mill a little section off of here a little bit, just a bit. But from here on, I know the exact deck height of this 9.2, but it seemed to be a pretty good fit. Now that's how I positioned the gasket before I put the manifold on. All right, I kicked it all the way up. And let us see what happens. You just have to do a little modification there because you're offset, all right, to make it seal. But here's the AFR gasket. That's what I did. This AFR went up when I measured it 0.200. Okay, so it is, it's okay. It's not quite as aggressive as the TFSs are because of the obvious limitation. There's not much meat there on the top of the roof, and that needs to be epoxied or welded. Now we are looking at the TFSR 351 twisted wedge R on this 9.2 deck. Look how far that whole thing is, allowing us to put in a thicker intake gasket and raise the port a little bit more. That is absolutely great. And here you can see how far it is, how far that is. All right, so this is one indication of a good setup to do. Like I've always preferred the TFSR for big cubic inch or high RPM 351s, 9.2 or 9.5. Beautiful. Here's the picture. Again, my apologies, somewhat blurry. I can't find my doggone flashlight to zoom in there. The regular flashlight doesn't even do anything. Anyway, so here it is, and we will measure how much it went up compared to the TFS high port, which was severely milled. Okay, it went up about that much. Okay, according to the video that we had. So that's about 400s. Okay, give or take. And if you would have ran a thicker gasket, intake gasket, it would have bring it up some more. Perhaps another 100 thousandths or close to that. That's what I like with the TFSR. Look at the distance and how your 700s, 3/4 of an inch thickness here to the top of the port. So you could really move that up big time. Okay, So that is impressive. That's why I like these heads to be raised, and then for big inch, cubic inch, or big inch 351, 9.2 and 9.5. Lots of RPM for the 9.2, big inch for the 9.5. Perfect. TFS high port and a TFS R twisted wedge. Look how much more area you have there compared to that. Okay? So you can just see who has more potential to be raised up. And the R is just vastly superior. Look at that, the difference. There's quite a bit there that could be moved up. Therefore, the question is, why on a 9.2 deck? Don't you want cubic inches? Well, let me repeat again on the previous video. We have run a 9.2 deck, and I had two perfect examples of big strokers. They really didn't do any better, considering they had a better intake, perhaps a better cylinder head because of the cubic inches, and I'm sure they put in a lot of CFM into those heads. Now, airflow sometimes doesn't mean you have more airflow, you're going to make more power. There's other issues there. Mixture motions, thermal efficiency of the combustion chamber, cylinder head design, all these things come into play. Even how hot you run your engine or how cold you run your engine. And at this point in time, the big stroker engines, be it Chevy, Mopar small block, or Ford, will not RPM as easy as we have a short deck. There's the reason Ford came out with a Cleveland as opposed to racing the Windsor layout. In fact, during the Bill Elliott days and beforehand, they did run the Cleveland deck heights. That's why you have the SVO blocks at 9.2 deck instead of 9.5. And the 9.5, of course, for people that like to make big cubic inches at the basically cost of RPM. And to make a long story short, the big stroker Windsors, the piston speed's too fast. It's a lot of stroke, even with a long rod. And what happens here is that when we run them in the 8th mile, they'll run just as quick. In fact, if everything was truly even, intake and carburation and the amount of nitrous that we run, or even NA, the 9.2 would have the upper hand. That's at the 8th. Okay? But when it gets to the quarter mile, guess what? The free revving capability of the 9.2 with a shorter stroke, guess what? It's going to pull away. It'll show a lot of mile an hour. In fact, let me get back and run this story. Irwin used to run a 306, a 10-second 306. It's pretty fast. Steel rods and everything. Stock crank, it'll run 1070, 1060. This said, when we wanted him to move up to a better cubic inches, Jameson, who was running for me at that time, we got him in Jameson's car. And he's used to revving his 306 at close to 8,000, a little bit more. All right? But basically 78 to 82 depends where it's at. When we got him in the car, we said, all you gotta do, okay, do the trans brake routine like you do with your 306, but only shift it at 6,800. He looks at me and Irwin like, that's all? Yeah, this is a big stroker engine. Got a lot of torque. Now, when he made his first pass, it's amazing. He followed exactly what we said. He goes, shifts at 6,800, not even 7,000, 7,200, and the doggone thing went 9s. Fast. Eventually, we step up on the camshaft, we are shifting at 7,200. That is quick. And what I noticed then is that you can have all these spacers on the dyno and keep adding spacers, the numbers keep going up. But that's not what it does on the racetrack. There's a point of diminishing return, then you start to go backwards. What that engine wanted was not too big of a plenum and not too small, just enough runner volume to feed every cylinder correctly. Because I think if your cylinder volume is not as much as your intake volume, meaning from runner to the cylinder head, there's going to be some issue about restriction, not feeding enough. All right, so it becomes kind of a balancing act there. It needs the plenum, but not enough. All right, so again, what it said on the dyno is not what it wants on the racetrack, and I have so many examples of that. Eventually, 72 is where the shift was at, and the combination went 930 in Las Vegas, like I stated from the previous video, at 149. That is moving, all right, and was through the muffler NA. So when Irwin went with that combination, it did exactly what we expected. It's a torque engine, not a high RPM engine. But since Irwin had a leaf spring car, Jameson's Fox body with that factory suspension, it's a little quicker, all right, by 2/10 at least. Okay, give that, even a 10, that's still an advantage. Just a Fox body is why everybody runs a Fox body with a big block Chevy, big block Ford, small block Ford, small block Chevy, whatever. I've seen him even on 2JZ. Amazing, okay? Because we know the chassis works. This said, eventually the 4-inch 170 gave up to a 4-inch stroke. Now we're shifting at 8,000 plus with the same combination of intake, heads, carburation. We were going that quickly. We had a Dominator on that big stroker motor because it had to feed the cubic inches. But now this one here wants to RPM, and it shows superior speed on the top end and also a tad quicker. It's basically an 8-second combination with a 4-inch stroke. And later on it was asking for more cylinder head, which we eventually switched over to a Blue Thunder, which is an updated Cleveland cylinder head. And it's impressive, and the rest is history. And now the combination is with this car with Huey. And of course, Irwin also has that engine, his second backup engine, which he called Old Reliable. It's been running for years and years. Probably had more passes than any car or Irwindale with that combination without braking. All right, it's an anvil. We could really depend on it and produce good power. It's got 540 with not ideal conditions, summertime, and I did some updating, racing the ports. Should go 530s, but fortunately Irwindale's close. Now the Chevy, I would say on the Legacy small block 350, guess what? You could probably do this manifold as well. I just wonder about the distributor shaft. You have to have an adjustable distributor shaft, because you kick up the manifold, the distributor go right up with it. And I think there's some out there with an adjustable shaft. The other reason I like the 9.2, because of it's more ideal. There's only so much stroke you can put in to keep the revability easy for the combination, and a long rod. When the deck height's too tall, the long rod is too long and heavy. So the 9.2 seems to be the best compromise. This is why the big block Chevy Pro Stock days, they cut the deck height. In fact, I had a big block Chevy here not too long ago. Well, many years ago. I think that was a 9-inch deck height, or a little bit over, 950 or something like that. But that's a big block that's been cut down, and that's truly amazing. And the amount of work put in it, because what they found out back then was, the deck height, when you're not running as much cubic inches in pursuit of RPM, you can conceivably take a 9.5 deck Windsor or a taller big block Chevy will rev to freaking 8,000, 9,000, 10,000 RPM, even back then in the 80s and the 90s. You have to find a way to bring the rod weight down, and that means a shorter rod and a shorter deck. and of course also shorter piston for weight. Then the RPM comes in. What is my favorite Windsor block or Ford small block? Best yet, 9.2 deck for serious efforts, be it NA or nitrous or whatever, or boosted. But I like to run them with a billet, fully counterweighted 302 main, with a smaller main, not the 9750 that the Cleveland has or the 351 Windsor race blocks. I like the 302 main. Okay, you just got to worry about the overlap between the main and the crank throat. All right, when you don't have enough meat there, you can have issues. But talk to your crank guy. I have Crower make my cranks out of a billet. There's no issue. Remember, when you have a short stroke and also a small diameter 302 main, that overlap gets to be less. But if you have light internals, it's not much of an issue, because the longer the stroke, even if you have the big main, like the 3-inch doggone Windsor main, that's a lot of bearing speed going on. All right, the surface speed's too fast because it's bigger diameter. The smaller it is toward the center, the slower the bearing speed, and there's hardly anything that you can feed the Windsor at high RPM. And a lot of people say, oh, you cannot turn those Windsor. Well, you can. All right, a 3-inch main, you open it up to 3 thousandths, a tau for every inch. Okay, so sometimes I run a 3, a 2.8 to 3 thousandths. Okay, bearing clearance on the main. When you try to run the 2.5 like you would a Chevy or a standard Cleveland or whatever, you're gonna starve the bearing and burn them up. Coated, preferably, and there you go. Coated, and then cut down on the bearing diameter on the rod and on the main, 2-inch, Honda Journal, whatever it needs. All right. Now, when you have a 9.2 deck, even if it's boosted, all right, turbo, it's so much easier on block than a supercharger, because there's a constant, pressure even during overlap. There's something holding it down, not like NA, especially when you get to valve float. The doggone piston wants to come up, there's nothing stopping it, and wants to smack the cylinder head, and that's when you pull the rods, really do big time damage. But if you have some kind of boost constantly, all right, on the upstream of the intake, there's always that holding it down. Okay, so even if you get on the overrim condition, as long as you don't float the valves, it's a lifesaver. That's why I see that I can pull a lot more horsepower and keep the reliability better than I would with a supercharger, which I feel comes in way too quickly. All right, especially when the guys are, and the blowers are already going, already freaking making noise, already doing and working, and then you mash it at lower RPM. Ouch, that's a lot of load on the main bearings and everything. All right, so the turbo is a lot more forgiving, and I feel like it's a better way to go, especially with the small tires they have today. We run on Dan, we run an 8.5 tire, 235. We can't really use too much stroke. We're going to blow the tires. But then again, you have all these things that you can pull back on the timing coming out of the gate, all right, or the nitrous. If it's adjustable, you can pretty much control that. But when you're holding it back, nitrous doesn't work very well at high RPM, because it's a constant flow, except if you have additional stages coming in, then you can compensate for that. But if it's allowed only one stage and you're high RPM, you cannot kick in another stage. It's a constant flow. It maxes out at that. So the flow is constant, the RPM is going higher and higher than ever. You're not getting the full effect. That's why when you hit nitrous on the lower RPM, you hit it, it takes off on you, you jump up, okay? And then on, what do you call that, at high RPM, let go of the button, kick it back again, and you just feel this, all right? Not much of a push or a difference. But at low RPM, boy, it really takes off. So that's That's one thing. Not opposed to like a turbo. The higher you go on the RPM, you can start building up the boost. And same thing with a supercharger, but not as good as a turbo, I feel. Anyway, just a little short story. Back then with Mike Termos and Dale Vastanchian when they started NOS, early on I found out that a lot of the guys that I was racing with at the Muscle Car Nationals back then, they have a lot bigger shot than I had a 150 or 175. And a lot of them are pushing 200, 250, 275 back then. This is the 80s. And what they're finding out is it becomes a quick draw. Here I am with my smaller unit, I can hit it earlier and I'll hook. And some of the other guys, like the big block Chevy guys I'm racing with, they got more torque and they're holding back on hitting their nitrous button because it'll blow the freaking tires. I won because I was holding back and I can hit it earlier than they do. And one of the things I did was I moved the doggone nitrous solenoid. You have the plate and the two solenoid. I was moving the nitrous solenoid farther and farther away from the carburetor because once they're even in there, I feel that once you hit the bottom, high pressure on the nitrous side, and then you got fuel pressure 6.5 to 7.5, maybe 8 on the fuel side. Guess what's going to get on the plate initially, in a fraction of a second? The nitrous. You have an initial lean condition. Lean is mean. You all know that. The car freaking rips and I blow the tires. The more I retard or pull back my nitrous solenoid, the hit isn't as hard, but I'm able to control it. Okay? And same thing with the secondary solenoid. I had 2 stages then, but I never did use it because the guy that I was racing with, the big block Chevy, his freaking engine grenaded. All right? But at that time, I could engage my second stage, which is another 150, I have a total of 300. And also the solenoid farther back, so it doesn't come in and blow my tires in second gear or whenever I engage it. So that's just one of those things that I found. We have no nitrous controllers, we have the ignition timing controllers then on our distributor. You're always looking at some ways to get advantage, and moving the solenoid lessens the hit of the nitrous. I found that early. Oh, and at the same time I told him, Mike Termos, especially and Dale, I noticed this doggone nitrous likes a lot of duration, man. He seemed to soak up the bottom end, and then that's when I can hit the nitrous. And they're smiling, going, okay, that's what we were finding out too. But this was years ago, all right? Man, I feel old.